Here is my topic about embedded system. Embedded system, any device that include a computer but is not itself a general purpose computer, hardware and software of some large system and expected to function without human intervention, respond, monitor, control external environment using sensors and actuators. Embedded in computer using CPU, that in that we got a output, input and memory. Characteristics of embedded system. There are several characteristics of embedded system. Sophisticated functionality, application dependent processor, restricted memory. Embedded system have to be efficient. These systems are dedicated towards a certain application. Many embedded systems are hybrid systems in the sense that they include analog and digital parts. Many embedded systems must meet real-time constraints, low power. Real-time operations are two: hard real-time and soft real-time. These are two real-time operations. Automobile embedded system. Today's high-end automobile may be 100 microprocessor, 4-bit microcontroller, checks, seat belts. Microcontrollers run dashboard devices. 16 by 32-bit microprocessors control engine. Vending machine. Vending machine, which we see every day in my day-to-day life. 8-bit microprocessors. GPS receiver. 16-bit microprocessors. DVD player. 32-bit RISC microprocessor. MP3 player. 32-bit R1SC microprocessor. NASA's Mars Sojourner rover. 8-bit Intel 80C85 microprocessor. Types of embedded system. Similar to general computing, PDA, video games, set-top boxes, automatic teller MC. Control systems, feedback control of real-time system, vehicle engine, flight control, nuclear reactor. Signal processing, radar, DVD player, MP3 players. Communication and networking, cellular phones, internet appliance. Sony AIBO ERS 110 robotic dog. 64-bit MIPS RI.
Here is my topic about classification of architecture. In that CPUs they are divided into memory, FPGA, AD, DA. In that human interface and diagnostics tools, DA is divided into actuator and software memory. In AD there is one sensor. Next we are going to see about how to implement an embedded system. Hardware, it is a processing element. In this peripherals, input and outputs are the main. Interfacing sensors and actuators. Memory bus. Software is divided into two types: system software and application software. Challenges in embedded system designs are how much hardware do we need, what is what size of the CPU, size of memory, how do we meet our deadlines, faster hardware or clever software, how do we minimize power, turn off unnecessary logic, reduce memory access. These are the challenges we face in embedded system designs. These are mostly challenging tasks for embedded system design. Next we are going to see about processing elements. General purpose microprocessor and microcontroller, DSP application specific processor, system on chip SoC. These are the processing elements in embedded system design. After the challenges we met in embedded system design, these are the processing elements in embedded system design. Next we are the topic about embedded hardware. Receive input, process it, provide output. first of all, it receives the input and processing the system. It gives output as a response. Microprocessor and microcontrollers. Uh, it is energy efficiency, high code density. These are the advantages in microprocessor and microcontrollers. What is microcontroller? Basically, a microcontroller is a device which integrates a large number of components of a microprocessor system onto a single microchip. A microcontroller combines onto the same microchip the CPU core, memory, both ROM and RAM, some parallel digital input and output. Here is the topic about microprocessor, CPU, board, computer, chip, pixel, example, interface, existing motor, zero, component control your time and module to move. The microcontroller to perform tasks for certain time periods is serious. IO ports to allow data to flow between the microcontroller and devices such as the PC or another microcontroller. And ADC to allow the microcontroller to parallel data to process. Microcontroller block. Why microcontroller? Low cost, small packaging, low power, construction, programmable, reprogrammable, easy integration in circuits for applications which cost power and space to critical single purpose.